Hi everyone, I'll be showing off this metal travel pad that I've been working on over the past couple months. It's built out of 1x1 aluminum extrusion for all the sides and center bits, and it uses 3x1 acrylic for each of the 4 panels. The overall length and width is about 17 inches this way and 17 inches this way. It's fairly light, pretty portable. It can be set up, put away after every session, which is what I do. It is an FSR pad. It uses Sujit software, so basically you can individually adjust the sensitivity of each of the panels, so you can make up more sensitive than left and right or down, which is what I tend to do. All the panels are hinged, so you can easily access the FSRs, and the way that I typically change the height of the panels is by stacking up tape. I use Gorilla Tape so it doesn't compress too much. It also features a custom PCB. That's this guy right here. This has swappable current divider resistors, so these are push to disconnect terminals. And it's also got a 5-volt barrel jack to power the LEDs, which I'm using WS2812Bs through the Fast LED library. You can change the lights based on Dom's light setup, and that basically is a modification to Sujit's code that permits light color changing from the online interface. So for example, this is Brazil here. See how the lights change. So the overall construction of this pad is 1x1 aluminum extrusion, and it's held together using corner couplers and also some inside 90-degree brackets. These guys probably aren't necessary at all. I added them onto the order because they were cheap. So basically there is your 2 side rails. So here's side rail 1, side rail 2, and then of course there's a front rail 1, front rail 2. Of course it should be back rail and front rail. These form the outermost 17 by 17 inch perimeter of the pad, and then there's these interior rails, one here, that basically form what will hold the center panel. The inside interior rails, these 2 guys, form the rest of the center panel structure, and the center panel itself, not pictured, is mounted on top of these risers. Interior top rail 1 and 2, and then inside interior top rail 1 and 2. These are 1 inch by 1/2 inch. I think they're also known as low profile extrusion, and they're actually held down to the interior rails via flathead screws. Like I said earlier, all the panels are hinged. I have them all separately hinged here, and the way that they are mounted to the hinges is via flathead screw. I didn't want anything protruding over the top of the panels, want it to be nice and smooth, so I've got one of the modeled here. This is a 82-degree flathead screw. There's a bit of interference you see here in the CAD. I actually drilled it down slightly more in real life just to get it nice and subflush. And then there's this low-profile nylock nut on the far side. So basically it goes flathead screw in a countersink, looks like this, through the acrylic, through one side of the hinge, then directly into this nylock nut. Alright, so you'll see me here starting the assembly process. I ordered these extrusions from a place called tnuts.com, and I'm kind of mixed on whether or not I should recommend them. The material was relatively cheap, shipping not so much, but also came across the country. The biggest concern that I have with them is they didn't clean any of the machining, so they provided machining services, which was really a huge boon at this project because they could do all the cuts and countersinks for me, and I didn't have to handle any of that, but they didn't clean up any of the edges, and I thought that was kind of funny. So saw me doing all that with an X-Acto knife. Should have done that with a deburr. Didn't have one at the time. That's fine. Here I'm attaching the inside interior rails to the interior rails. And you'll notice that I'll also slide in the slide-in T-nuts ahead of time. Those, because they're not drop-in, it's a lot easier to plan how many you need in advance. The CAD really helps with that, and put them in while you're assembling it rather than trying to do it after you assembled it. I had to do that a couple of times toward the end of the pad build, but for the most part, all the T-nuts were in place. So inside interior rails coming in here, you'll see me work on the spacing, make sure everything is spaced correctly. I really didn't have to put a square on it, which was kind of surprising to me. The cuts were pretty square themselves, and just tightening up all the connectors seemed to be sufficient to bring the extrusions into alignment. So finishing up the inside here, you'll see me tightening stuff down. I didn't have a ball and hex wrench at the time. Highly recommended. Actually ended up buying a couple ball end sets just because of that. Here you see me getting what I believe are the side rails on here. Same as before, sliding the T-nuts ahead of time, knowing how many I'll need to use, tightening those down, checking on making sure everything is square. Connect on both sides, clean up the edges, and then screw everything down. For this first build, I actually did not put Loctite in any of the screws. I was just making sure everything went together properly, I wasn't missing any pieces, and everything aligned like it should have, which honestly wasn't too big deal to go back through and put in Loctite later, so I was happy with that overall decision. And tightening up some of the corners here, you'll see me get both of the, I believe these are the side rails on. Sometimes it's easier to stand it upright. You see me standing it up on the bench facing right toward the camera. And basically getting both sides aligned. And here you'll see I lay out the top rails and the center panel. Center panel is just from my arcade machine, but you could stick something else on there instead. And yeah, that's pretty much it for the initial assembly. Here you'll see me measuring out the first panel. Panel again is 3 inches across, 11-inch long acrylic. I had to cut the 11-inch direction as I just bought 3-inch stock. This was actually one of the more time-consuming parts of the project. I again wanted to prove that I could do it with hand tools, so I started off with a hacksaw that I borrowed from my community tool share, and it took quite some time to get through this first bit. Partially because the saw was dull, partially because my technique was bad and I didn't have a vise. But the cut itself ended up being pretty good for having a hand tool, I'd say. Obviously sticking something like a bandsaw on it would basically do it instantly and probably yield a better cut, but for a hand tool on my electronics bench, I wasn't about to complain. After cutting all 4 panels, I drilled 4 1/4-20 clearance holes in each of them to accommodate 2 hinges per panel for a total of 8 hinges. Each of the panels I used a countersink bit to create a nice flush surface that the flathead screw could mount on. The hinges themselves were a little bit too small for 1/4-20 clearance holes, so I just drilled those out with a 1/4-inch drill bit as well. Outside of the panel cutting, the other big machining aspect of this project was mounting the top plates. I basically drilled clearance holes for both the 1/4-20 and for the flathead screw, such that I could just clamp it down to the T-nuts. After preparing all the panels, it was time to install them. This process was pretty straightforward. Just removal of the film from one side of each panel, and then stick through the flathead screw from the countersunk side, stick it all the way through the drilled out hinge, and then into a low profile lock nut on the far side. I had to remove the film ahead of time so it wouldn't get trapped in between the hinge leaf and the acrylic, but I did leave the other side of the film on so the panel wouldn't get stretched up during the rest of construction. Then tightened all those screws down and attached the other leaves of the hinges onto the side of the pad using the T-nuts that I had previously placed in. So pretty straightforward, easy to do process. And after all the panels are mounted, it was then just time to install the top rails here. Like before, just stuck the flathead screw through the clearance holes that I had drilled earlier and screwed them directly down onto the T-nuts that I had previously installed in the extrusion. Once that was done, I could get the center panel in place, check all the clearances to all the panels on either side. So the lights preparation was one of the cooler parts of this project. I used rigid WS2812B, I believe they're called, light strips I bought from eBay. They're individually addressable light strips, and I cut them into 4 sections, one for each panel. What I chose to do was solder bent male headers onto each of the ends of the 4 light strips so I could then daisy chain them together, and you'll see me here setting them up into the test bench. Here's a better picture of the bent 90-degree male headers, and here's all 4 of the light bars wired together and on my test bench. After finishing up the lights, I decided I really wanted a nice white base plate to improve reflectivity, so I ended up buying the 17 by 17 by quarter inch HDPE sheet, and I drilled 4 holes into the corners and then used the same countersink bit to countersink all those holes and provide a nice spot for the flat heads to grab onto. I'd show some video of me soldering the board, but it's a little bit too hard to see, so just pictures instead. The board I got from All PCB. I've pretty quickly started off by soldering the current limiting SMD resistors in place, and then the SMD light emitting diodes. I used blue, and then finished up with the headers, capacitor, reset pin, and 5-volt barrel power jack. Got the female headers on there for mounting the Pro Micro, and then mounted on the terminal block for the swappable current divider resistors. When finished up, Pro Micro resistors in place, it looks like this. You don't need to make your own PCB if you're building a pad like this. You can just use a breadboard, but I find PCB design fun, so I decided to go this route with my design. So here you'll see me mounting the FSR itself. I use standard Scotch double-sided tape. Made sure to clean off the brackets real good with alcohol first, just to make sure there wasn't any grime stuck between the tape and the FSR. Then, after getting the FSR taped in place, I used Gorilla tape, which is my go-to tape for pad modding. Stacked it up on the underside of the panel until I got the height approximately correct to rest on the FSR and approximately level with the top of the center panel. So after getting the rest of the FSRs and the board itself in place, I then crimped a bunch of wires. Not going to show that here because it's long, extremely boring. I used DuPont style connectors to connect both the lights and the FSRs to the board. Here I'm using some zip tie mounts to manage the wires and make sure they don't get trapped underneath any of the panels when I'm stepping on them, and just putting some finishing touches on getting the USB and 5-volt DC power jack in place, and then finally closing things up and working on the lights programming in software. I didn't show this at all, but the way I ended up mounting the center panel was using Scotch double-sided mounting tape. Worked pretty well. Here's me testing out the travel pad by playing Asymmetry. This song has 16th note streams at 184 BPM. Good players can go a lot faster than that. I personally can't, so it's hard for me to speak to how this pad handles at the higher BPM. So that concludes this video. It's a little bit hard for me to recommend anyone to build this pad, especially before I run the numbers on how much it costs to construct it, but I assure you it's significantly more expensive than some of the cheaper travel pad options that others have made out of wood or just polycarbonate or other materials. So if you're looking to get into building travel pads on the cheap, I'd definitely look into some of those other pads first, but if you really do want a metal travel pad, I'll be releasing all these designs as open source as soon as I can finish the documentation. Thanks for watching. That was all.